Hello and welcome to our unit over nomenclature. At this point, you should have your polyatomic ions memorized, and if not, you need to work on that immediately. You will need your periodic table for reference for all the videos in this unit as you take your notes. The governing body responsible for chemical nomenclature is the International Union of Pure and Applied Chemistry, or the IUPAC system. There are two major divisions of the IUPAC system. First, there is organic nomenclature. This involves elements containing carbon bonded with hydrogen, oxygen, nitrogen, and sulfur. This is beyond the scope of our class and is a college course. Then there is inorganic nomenclature, which is everything else and is divided into three categories: covalent or molecular compounds, ionic compounds, and acids. To name and write formulas for chemical compounds, you must be able to classify elements first. You have already learned that in our periodic table unit. The metalloids are the purple elements over here. The nonmetals are to the right in green, and the metals is everything else in yellow. Metals make up most of the periodic table. We will often refer to groups or columns by names also. Again, you have learned that in the periodic table unit, so you can take a look at the slide and make sure that you know the names for all your groups in your periodic table. Most elements exist as part of molecules or covalent compounds or as ionic compounds. Only noble gases truly exist in their elemental monoatomic form in nature. How do we name monoatomic elements? We just name them as they appear on the periodic table. So for example, Na is sodium, F is fluorine, etc. We name diatomic elements just the same. There are 7 of them which you need to memorize. They are hydrogen, oxygen, bromine, iodine, fluorine, chlorine, and nitrogen. A useful acronym for remembering them is I bring clay for our new hut. So iodine will be I2, bromine Br2, chlorine Cl2, fluorine F2, oxygen O2, nitrogen N2, and hydrogen H2. Monoatomic ions are atoms that have lost or gained electrons. Again, this is review. The cation usually comes from a metal and electrons have been lost. We name them by writing the element name followed by the word ion. So for example, the K+ ion is the potassium ion. Anions usually come from nonmetals. Electrons have been gained. Element suffix is changed to "ide." So S2- is sulfide. Now, we can also say the sulfide ion. Remember, cations and anions are all ions. So we recognize negative ions because of the "ide" ending, but it is still the sulfide ion. Polyatomic ions are 2 or more atoms bound in a covalent bond with a charge. You should have memorized these by now. So for example, NO3 with a -1 charge is nitrate, and PO4 with a -3 charge is phosphate. The oxidation state refers to the charge on an ion. It is the degree to which an atom is oxidized when an ion is formed, or how many electrons have been taken away. In an unbound neutral element, the oxidation state is 0. So for example, a neutral sodium atom will have a charge of 0. If the element is diatomic, it is also 0. So all the diatomic elements will also have an oxidation state of 0. In a monoatomic monovalent ion, it is equal to the net charge on the ion. What does that simply mean? Sodium with a charge of +1 has an oxidation state of 1. Chlorine with a charge of -1 has an oxidation state of -1. Magnesium +2, and sulfur -2. The sum of the oxidation states of the atoms in a compound is 0, and that is because compounds are neutral. So for example, in sodium chloride, sodium is +1, chlorine is -1, and that makes it 0 when we add them up. In magnesium sulfide, we have magnesium as +2, sulfur is -2, so the charges balance out, and we also get 0 when we add them up. The sum of the oxidation states of the atoms in a polyatomic ion is equal to the charge on the ion. We will not go into the details of how to work that out. That is for a later unit. Now let's talk about multivalent ions. If an atom has no consistent charge, meaning that it loses or gains a variable amount of electrons in chemical reactions, it is said to be multivalent. Elements in groups 3 to 12 and 14 are multivalent. Here they are on the periodic table, groups 3 to 12 and group 14. They form at least 2 or more different ions. When written, the oxidation state is given in Roman numerals following the cation, and it is written in parentheses. This is called the stock system. For example, copper can be copper 1, so copper with Roman numeral 1 has a charge of +1. Or it could be copper 2, so copper with Roman numeral 2 has a charge of +2. Lead could be lead 2 or lead 4, so lead 2 will have a charge of +2, and lead 4 will have a charge of +4. So the Roman numeral tells you the oxidation state or charge. There are 3 atoms, however, in these groups that do not form multivalent cations. They form monovalent cations, and they are silver, zinc, and cadmium. You have memorized those before, but as a reminder, zinc is +2 over here, cadmium is +2, and silver is +1. Make sure that you memorize those. Here is a good visual recap of oxidation states or charges of ions. So group 1 is +1, group 2 we have +2, group 13 is +3, 15 -3, -2, -1. Then we have our multivalent area over here and over here in group 14. And finally, we have zinc, cadmium, and silver, which you have to memorize, are monovalent. Quaternary compounds consist of 4 different elements. So here we have nitrogen, hydrogen, phosphorus, and oxygen. Both ternary and quaternary compounds will usually contain a polyatomic ion. Ionic compounds are composed of a cation, usually coming from a metal, written first, and an anion, usually coming from a nonmetal, written second, and they are joined by strong electrostatic forces. Either ion could be replaced with a polyatomic ion, and they form 3D crystal lattices, as shown in the picture over here. Some examples would be sodium chloride, where we see the metal ion is sodium, and the nonmetal ion is chlorine. Then here we have aluminum sulfite, so we have a metal cation, and the anion has been replaced by a polyatomic ion. Molecular or covalent compounds are composed of non-metal atoms, only non-metals, joined by covalent bonds. The combined attraction of the atomic nuclei for each other's electrons attracts the atoms to each other in a shared bond. Covalent bonds share electrons. Metalloids may also be present in molecular compounds. So when you're forming molecular or covalent compounds, we are talking about the elements in this region, the purple and the greens only. So we can see some examples over here, and if you notice, there are no metals involved in any of those compounds. Acids are composed of a hydrogen ion or several hydrogen ions covalently bonded to either a monoatomic anion or a polyatomic anion. So for example, HF, which is hydrofluoric acid, has your hydrogen ion here bonded to a fluoride anion. Then if we look at one with a polyatomic ion, we could have H2SO4. We have 2 hydrogen ions bonded to the sulfate polyatomic anion. It is really important that you realize that acids are classified as covalent compounds also. Now, water, H2O, has hydrogen in it. It is not an acid. Water is just classified as a covalent compound. Bases are ionic compounds composed of a cation and the hydroxide anion. So for example, we have NaOH, we have the cation sodium followed by the hydroxide anion. Or we have calcium hydroxide, the cation is calcium followed by 2 hydroxide anions. One exception is ammonia. Ammonia has the formula NH3, so it is composed of nonmetals only, so it is classified as covalent, not ionic like all the other bases. However, ammonia is also classified as a base because when bubbled through water, it forms ammonium hydroxide. So now we have the OH associated with ammonia, which classifies it as a base. Make sure you note that exception. This concludes our video for today. Come to class prepared with good notes.